Okay, we're on day 3 of sequences and series. Flip back a page or two in your notes to get to these little 2 half sheets. In class, normally these 3 are a bell ringer, just a refresher. If you'd like to do them and submit them for some points, great. If you don't, that's fine. This is for virtual kids, so if you're watching this and you're not completing school virtually, just ignore. And then this is usually also part of the bell ringer to get ready for the day. It says, in an auditorium, there are 10 seats in the first row. There's an additional 4 seats for every row after. How many seats are there total? So I asked students to go ahead and find it. So row 2, we know there's an additional 4 seats. So we say 14. Then row 3, there's an additional 4 seats, which is 18. Row 4, there's an additional 4 seats. 5, there's an additional 4 seats. 6. Okay. Some people say, 46. They want to know the total. So here is an arithmetic sequence, and then we're going to add them up. So 10 plus 14 plus 18 plus 22 plus 26 plus 30 plus 34 plus 38 plus 42 plus 46. That's 280 seats. Okay, and then I kind of sit and ask the class, I'm like, hey, is there a better way to do this? Is there a better way to do this? And then they might sit there. And I go, okay. Look at seat, or row 1, I should say. It's 10 seats. And look at row 10. That's 46 seats. When I put those together, what do I get? Okay. Now let's work backwards. I have 42 seats in the row previous. In the next row, 14. When I add those together, what do I get? And continue. And I continue. And I continue. So there were 10 rows or 5 pairs of 56. So what you do is, however many seats you have or how many objects you have, call it n objects, divide it by 2, and that gives you your amount of pairs. And what you do is you took your first term and you added it to your last term. We don't know if it's going to be 10 or 20. And then that's it. That's how you do it. So this is how you find the sum of those n terms. And that's it. That's your lesson for today. So this is called not a sequence, but a series. Okay, not a sequence, but a series. And that's what we're going to do today. So starting at the beginning, just kind of ignore the top because we already did a better example of that. It says a series is founded when terms of a sequence are added. An arithmetic series is the sum of the terms of an arithmetic sequence. The sum of the first n terms is called a partial sum or summation and is denoted S sub 10. Okay, so it's just called a partial sum because you're not adding up the entire sequence, you're adding up a partial of the sequence. You're adding up partially of it. Okay, so there's a few formulas that you can use. You can use the one I used or another one. Okay, and it's in your textbook too. So I'm going to go to chapter 10. Let's find it because I'm not familiar with it because I don't use it. Let's use the one that I naturally think of, but I would like to expose you to all of them. Okay. Okay, so there is both formulas. Okay. So there's the one that I gave you, dividing your pairs or dividing to get your pairs and adding the first two terms, or how many terms you have divided by 2. 2 times the first term plus n minus 1 times d. Either formula, I don't care. So the general is having your first term and your last term. Your textbook says a sub 1 and a sub n. I don't care either way, whatever you want to write. I like saying n divided by 2, your first term plus your last term. It's just easier logically to think of. And if you're given the first term and the common difference, you can use this formula as well. I never really have, but you can. Okay, so it says find the sum of 12 plus 19 plus 26 all the way to 180. So I'm going to use my formula. They said sum. I see that it's arithmetic. So I see that, oh, I don't know how many terms I have. I know my first term is 12. I know my last term is 180. But I need how many terms I have. Well, my first term is 12. My last term had to have been 12 plus my common difference of 7 times n minus 1. So to find 180, I know it's my first term plus 7 plus 7 plus 7 n minus 1 times. Well, do I know my last term? Yeah, it is 180. Now I can figure out what n is by solving for it since I have everything else. That's 25. That means there was 25 terms. Could I have written this down on a piece of paper, 12, 19, 26, 33, and gone on and counted the numbers? Yes. I was desperate. I could have done that. But I realized if I have one formula and I don't have all the things, I need to hop over and use the other formula. So here's the thing. If you're not even sure what you're doing, write out everything you have. Write out all the formulas. Plug in everything you have and then solve. I know 180 plus 12 is going to be 192 times 25 divided by 2. So that's 2,400. So when I add all these numbers up, it's going to be 2,400. Okay, we're just going to do the back page. It says find the first 3 terms of an arithmetic series. So they said arithmetic series. Series is when you add up arithmetic sequences. So I know I'm going to use this formula. You can write A1 or T1. It doesn't matter. I go back and forth. Well, I know A sub n is 79. I know A sub 1 is 7. I know the sum of it all is 430, but I don't know n. Do I even need to know n? They want the first 3 terms. They want term 1, they want term 2, and they want term 3. I have term 1. In order to get to term 2, I need a common difference. I have n here. I don't have a common difference. This formula only did so much for me, so maybe I should do the other formula. T sub n equals T sub 1 plus D minus n sub 1. I have the nth term or the nth term, which is 79. I have the first term. I don't know the common difference. Do I have n? I actually do. If I solve and bring that 2 over, 840, and simplify this inside 86, 840 divided by 86, that's not a pretty number. So what did I do wrong? Oh, because this is times 2, 860. So n is 10. So that means there was 10 terms. So if there's 10 terms, that means if I subtract 7, my common difference is 8. Okay, so let's recap. They wanted to find the first 3 terms. They gave me the first term. I don't know the common difference. But if I use this formula, I can't find the common difference unless I knew n. I can't find n unless I use this formula. So if you're like, what would I have done? Write all your formulas out, solve for what you can, go from there. If you add 8, you get 15. You add 8, you get 23. There's the first 3 terms. All right. Sometimes this has a little different notation than the S sub n. This is the same thing as this. It says sigma notation. Sigma, it's the Greek letter in the alphabet. Okay, it means to sum or to add. The sum of a series can be written shorthand using sigma notation. So this means that you're going to substitute in 1 all the way up to whatever this number is. And f of k is your formula. So if you look here, this is saying I'm going to substitute in 1. I'm going to substitute in 2. I'm going to substitute in 3. I'm going to substitute in 4, all the way up to substituting in 12. So I will get 4 plus 2, 6, 10, 14. Oh, I see that I add 4 every time. 18, all the way up to 50. And then summation means you just add them all up. Well, an easier way to do that would just say, okay, use my formula. How many terms do we have? 1 through 12 is 12. What's my first term? I plugged in 1, I got 6. What's my last term? Substitute 12, I got 50. So 12 divided by 2 times 56. So how many pairs of 56? 6 pairs of 56. So if I took 1 and then 2 all the way up to 12 and I added them all up, I would get 336. Using this formula would be easier. Here, we're going to do the same thing. We're going to use our formula and substitute in what we know. Well, what's my first term? Oh, we start with 4. That's okay. So my first number is when we start with 4. 6 times 4 is 24 minus 3, 23. The last term is 6 times 18 minus 1. Is 107. First term, last term. How many terms do I have? A lot of students will say, oh, you have 18 minus 4, 14 terms, but that's incorrect. Because we said we had 12 terms up here. 1 through 12 is 12. But what's 12 minus 1? 11. You have to remember to add back on that term. So 18 minus 4 is 14. Add back on, I actually have 15 terms. Yeah, think about it. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15 terms. So be very careful when you subtract, it's not 14. This is going to be 7.5 plus 130. That's 975. Okay. All right, that is it for arithmetic series. Tomorrow we'll talk about geometric.